Hello, everyone. A very warm welcome to all of you for the BIM Coordinators Summit 2022. My name is Kushagra, and this is Fireside Chat with Varun Bhartiya. Varun is an inventor, technologist, entrepreneur, and a visionary leader in the field of 3D design and visualization automation for the last 15 years. He is a thought leader who is driven by his passion for enabling businesses around the globe in the AEC and manufacturing industry to become better, smarter, and faster by creating innovative and powerful design and visualization technologies. After working with giants like GE and 3D PLM, he started nCircle Tech in 2012 with the vision to automate the design workflows. He is an IIT Madras alumnus, a father of two adorable sons, and also an awesome badminton player. Varun, thank you for being here.
Thank you, Kushagra, and thank you all for joining. I hope this session will be worth your time.
Without further ado, let's get started. In today's live session, we'll explore how technologies like artificial intelligence and machine learning can usher in Automation 2.0 and create a sustainable impact in reducing the global carbon footprint. So, Varun, before we dig deeper into the scan to BIM automation, what are your thoughts on the ongoing climate crisis?
Well, the climate crisis has been one of the focal point of 21st century, both within political circle and the construction industry. From Greta Thunberg calling out to the world leaders to President of USA Joe Biden running for the office on the agenda of climate change, the call for action is only getting louder. We are all aware about the heat wave spreading across the Europe, with many countries facing record high temperatures. The scenes of firefighters tackling wildfire seem very close to the scenes from the world-ending movies. Did you know that according to the World Meteorological Organization, there's 40% chance that 1.5 degree temperature threshold would be exceeded by 2025? In 2021, IPCC released a report that revealed the severity of inactions on climate change. COP22, COP26, and G7 summit have resulted in firm commitment to sustainability, and many countries have taken aggressive carbon goals. We are all realizing the impact of climate change. I have two young sons, and the thought of them facing the end of the world in near future is terrifying. Hence, the only way forward is to become more optimized and more efficient to clear our carbon debt and build sustainable future for next generations.
Well said, Varun. I think parents like you will eventually truly save the world. I'm glad you spoke about reducing the carbon footprint. Here is a graph that will give you a breakdown of the global carbon emissions. As you can see, the AEC sector, the architecture, engineering, and construction sector, are responsible for around 39% of global greenhouse gases. So, what do you think? An optimized and efficient workflows in AEC, can it bring a significant contribution to curbing climate change?
Absolutely. One such key initiative is Golden Thread Initiative. Since its conception in December 2020, most organizations have joined to help pilot waste that organization can contribute a standardized and produce a standardized golden thread for both existing and new builds. In order to retrofit to reduce carbon emission, we need to quantify the energy requirement in existing state of the building and improve and any improvement possible. To do this, we need digital data. Under COP26 initiative, UK needs to retrofit 26 million homes by 2050.
26 million homes. That's quite a big challenge, isn't it?
Yes, let me break it down for you to truly understand the scale and enormity of this. Can you really guess how much that translate into per day? It is about 2,600 houses to be refurbished every single day till 2050. Do we have digital models for these houses? No. And hence, there is a need to innovate and speed up the process to achieve our goals, and we need lots of data to estimate all of this. We need 3D models to make this happen faster.
So, Varun, is that where Automation 2.0 comes in?
Simply put, Automation 2.0 is increasingly optimizing every workflow. We are moving from reactive to proactive and predictive approaches. Considering the evolution of new computing technologies and artificial intelligence, Automation 2.0 isn't just a buzzword. Instead, we are entering in a phase wherein computers now learn from experience and from the data. Computers can often do better prediction of patterns as compared to humans.
Makes sense, Varun. But where does scan to BIM comes into the picture?
Scan to BIM is the term often used these days in BIM industry. Scan to BIM has emphatically influenced AEC industry by speeding up the digital modeling BIM modeling process by providing the as-built models for retrofit and improvements in a very cost-effective manner. However, the current typical workflow of Scan to BIM involves the laborious task of taking the registered point cloud data and turning them into BIM model one entity at a time. This creates big barrier for adoption of Scan to BIM. Hence, using Automation 2.0, we can leverage the power of AI ML and make Scan to BIM smarter and faster.
Interesting. But how does scan to BIM help reduce the carbon footprint?
Scan to BIM helps reduce the carbon footprint in multiple ways. The very first being speed of conversion. This enables same team to do more in less time. Second, it has much better accuracy because we are taking all the measurements right out of the BIM model. Earlier, the process would have been based on a lot of assumptions and hence very error prone. This process also creates a digital copy which can then be utilized for other initiatives such as golden thread initiatives or other future improvements.
That sounds quite promising and exciting. Can you dig deeper and explain how intelligence and machine learning does this?
Yes, sure. Let me show you a video. If you can allow me to. Yeah. All right. I hope you can see my screen.
Absolutely, Varun.
So here's an input point cloud data of a typical UK house. We have created an automation within Revit that only asks for E57 file of any kind of point cloud data that you have scanned. This then goes forward to cloud for entire automated processing and returns back with a JSON file which is then used to create BIM entities. The ultimate objective obviously is to create that magic button which turns the point cloud into BIM model. But let me show you where we are and what we have achieved. Once this processing is completed, what you get is the first cut BIM model created entirely automatically using the machine learning algorithms. Let us now, what modeler is doing here now is only checking for the accuracy of what the automation has really created. As you can see, walls with different thickness, different properties have all been created automatically. We are we check for different floors. You can see different walls. These you can see some of the model lines that have been created as a part of our automation. All this, even the windows, the entities are created exactly in the location where they are supposed to be with appropriate and correct dimensions required for the heat loss calculations. Let me show you what is happening in the background. uh, we take the original point cloud data, we even crop it automatically on the backend. Once it is cropped, it goes through the segmentation process. This is the most important step where machine learning is adding lot of information to the point cloud data. Without this, point cloud data is just XYZ and color information. But machine learning groups certain set of points together to call them as, let's say, wall points. These group of points represent a wall. These group of points, for example, here represents a door, and so on. This then enables our team, our algorithms, to further implement all statistical stuff to fit walls on the given point. So here what you see is wall segmentation results, only wall points extracted from the entire point cloud data, which then makes it easier and more accurate to detect wall planes and exactly the walls. After all the combination cleaning, we get to exact set of wall lines, which are then transformed as a part of JSON file, like different information about walls, doors, and windows. And finally, we create the BIM entities in Revit model, thus speeding up the entire process really significantly. We also do a lot of deviation check on the data that has been created. So we compare what has been created, what is modeled. Anything that is in red is not modeled or like part of more deviation as compared to the point cloud data. This helps also the QC process, thus speeding up the process of QC significantly and making enabling us to deliver very accurate models. As you can see, a lot of furniture data is not required, hence not modeled and also marked in red. We can look at this data in multiple ways in different layers. So as we span through or scroll through the top of the house to the bottom of the house, very easy to find out any deviations across your entire model and thus speeding up the process. We don't stop just at creating the BIM model. The ultimate objective is carbon reduction of carbon emissions. So the first step to that is taking all the measurements to understand the heat loss from the given model. What I'm showing you here is once the BIM model is created, there are many measurements that we take up all automatically. For example, exterior wall information. Anything that can be insulated in the external wall surface is extracted automatically, and we generate all this data as a part of Excel reports, which then feed into many heat loss calculations. We find out information also about rooms adjacencies, which room shares a common wall with another room, and what are the rooms above and below. These are very important to understand the heat loss calculation. You might have one room which is centrally heated and maybe a few other rooms which may not be. All of this, you can imagine, helps us feed very accurate information to the entire system and thus enabling a very accurate and much faster uh, scan to BIM process, end to end process automated.
So, Varun, quite interesting. You pop the hood and you have shown us how it works. But from the end user perspective, what's the effect on the turnaround time? How much optimization are we talking about?
Before this entire process, the UK energy company, which is trying to reduce the energy consumption of UK houses, used to take about 8 to 10 days from scanning to conversion to BIM model to doing all the calculations and generating a tech survey report. With this approach, where we have automated almost every step of the way, we were able to bring down the entire process just to 2 to 3 days. That in itself is about 80% time saving.
Well, that's the power of smart automation, isn't it? In fact, as you mentioned earlier, for the scenario in UK where we were talking about 26 million homes, that could be a perfect use case for implementing a solution like this, isn't it?
Absolutely. 2,600 houses in a day will need really astronomical amount of workforce, making this initiative almost impossible. Even with a traditional scan to BIM approach, making sense of point cloud data manually would need so many human hours that would completely crush this initiative. Hence, to retrofit these homes and to make them energy efficient, we need to adopt new innovations. and use solutions like ML powered scan to BIM technology and Revit automation. This is very critical to be able to realize the dream of energy transformation and for the net carbon zero future.
This is quite something, Varun. Now that we have seen how it works for our audience, would you just list down the advantages of this entire approach?
Yes, sure. First and the most important is speed. The time consuming steps have been all automated, which then speeds up the process and enables the team to do more in less time. The second biggest advantage of this process is it also avoids multiple visits on the site. It is very difficult to get access to house for any measurements again and again. So in one scan, we get the measurements for heat loss, wall insulation, and all the future improvements. We also create a kind of a digital archive, so it is possible to cross verify the data in any time in future. The output generated is compatible with any other downstream BIM applications. And last, but the very important, this entire process and approach gives a very premium experience to homeowners. A lot of people really like the fact that a team of people with advanced scanners, drones flying over, take all these measurements in the matter of 20 minutes. This is just amazing. This also reminds me of something like Star Wars stormtroopers entering your house with all those high tech gadgets and really making that happen. This premium experience helps spread the word and makes like people invite such teams to take measurements and do reduce the carbon emission. And I think that is one of the best advantages of this approach.
Well, Varun, as you mentioned about stormtroopers, it makes me excited as a homeowner. I mean, I'm looking forward to getting my house refurbished and become energy efficient. It would be great to watch the whole team in action, scanning and eventually turning my house into something that contributes to the greener cause. So, Varun, what do you think is going to be the future of the scan to BIM technology?
Long time back when I was a kid, there were many data entry companies. Really, if you would not believe me, they used to get photos of handwritten forms, and they were manually typing the data, really digitizing the data. But such companies, with advancement of OCR, such companies do not exist anymore. Then there were photos. Initially, photos did not have any intelligence. But now, with Google and Facebook, each photo is automatically tagged. This is a photo of Varun, this is a photo of Kushagra, and so on. Even to an extent, Google can even describe that this is a photo of a boy playing with a ball. Similarly, I feel that currently there is a lot of manual process to convert point cloud data to usable information. And I think in future we will be able to get such information much faster. Interestingly, number of photos on the internet increased exponentially when camera was added to phones and people could easily capture photos. Similarly, now iPhones have LiDAR scanner. Soon there will be so much point cloud data that it is impossible to process all of it manually. ML powered scan to BIM will bring that intelligence to the point cloud data, thus enabling more innovative workflows in the future.
Varun, that is something that really opens my eyes. How artificial intelligence and machine learning can really change the future. But whenever we talk about such future technologies, the biggest fear that people face, especially in AC industry, is that will these technologies eliminate the need for humans in project delivery or even for the laborers on site? What do you feel? Is this fear founded on some rational?
The answer obviously, Kushagra, is no. This was the same thought process that was there when computers started proliferating everywhere and being a common thing in every household. But it never reduced the work that we have at hand. We have astronomical amount of uh, houses to be refurbished and to meet our carbon goals. We need all the innovation that we can to make that carbon goals really possible. I think there is no other option that we have other than adopting such technologies and making it faster and better.
I think, Varun, you're bang on that these technologies are going to just complement the human capabilities. So, Varun, before I open the stage for audience questions, do you have any last words?
Yes, I would like to conclude by saying that we are doing our bit, speeding up the Scan To BIM process using AI/ML, creating smarter BIM workflows. However, as the old saying goes, that it takes whole village to raise a kid. Hence, all of us from AEC industry will have to come together and reduce the carbon footprint to build better future for our children. I hope all of us are equally committed to greener future, and we will need many more such innovation to meet our carbon targets. Our Scan to BIM is first of the many steps in the right direction. We all need to leverage technology to make the future a better place. Thank you so much, and I hope you enjoyed the session and I hope it was worth your time. Please enjoy the rest of your session.
Thank you, Varun, for this awesome fireside conversation. Just like our audience, I'm ready to do my bit to save our pale blue dot. I've already bombarded you with loads of questions, so now it's time I open the floor to our amazing audience of the BIM Coordinator Summit to come forward with their interesting questions. Audience, the stage is yours.